This time I'm going to show you how to do or draw what's called an orbital diagram. And I'm going to go back and I'm going to use phosphorus again. So phosphorus, 15 protons, okay, means it's 15 electrons. In the last video I showed you that the electron configuration would be 1s2, 2s2, 2p6, 3s2, and 3p3. Okay, looking just to check. 2 plus 2 plus 6 plus 2 plus 5 makes 15. So everything's good there. So we drew that right. Let me get rid of those. So what an orbital diagram is, it's a different way of modeling what we're ultimately going to use to predict the formulas for compounds. The rules are this. If you have a S sublevel, something's not working, S sublevel, that's going to get a box, and that box represents one orbital. A P sublevel has 3 orbitals, so it gets 3 boxes linked like this. A D with its 5 orbitals would have 5 boxes like this. And an F with its 7 orbitals is going to have 14 boxes. No, 7 boxes. 1, 2, 3, 4, 5, 6. And what you do is, if I'm going to do an orbital diagram for phosphorus, I would say, okay, I have 15 electrons to account for. In the 1s, there's a box. And in that box, it is going to contain 2 electrons. That number 2 right there, represented in an electron configuration for the number of electrons, now in an orbital diagram looks like this. 1 arrow up, 1 arrow down, representing the fact that if 2 electrons are going to be in the same orbital, they have to have opposite spins. So that's the first one. Then I go to the 2s, and it's a single box because that's what S is. It has 2 electrons in it, 1 up, 1 down. The next thing I come to are the 2 P's. P's have 3 orbitals. That's the XYZ orientation. So it looks like this. And since there's 6 electrons in it, it's going to get 3 up, 1, 2, 3, and then 3 down. 1, 2, 3, looking like that. Then I go to the 3s, back to 1 box representing 1 orbital, 2 electrons in it, 1 up, 1 down. That was those 2 right there. Then I go to the 3p with 3 boxes. Now something happens at this point, and it's called Hund's rule. And Hund's rule states that when electrons fill orbitals, they fill empty orbitals, or when electrons fill a sublevel, they fill empty orbitals first. So these 3 electrons right there, I need to place this way. 1, 2, 3. They're all going to be spinning the same way. So that's the electron configuration for phosphorus. And what it's going to, I guess, the incorrect way to have placed that, okay, what I was just talking about, would have been to take those 3 electrons and to have done this. Gone 1, 2, 3. This would never happen. Okay? This is bad. Can't happen. Okay? Can't work that way. So let's get rid of that. But that's Hund's rule. Sort of like the city bus rule. You always take the empty seat if one's available. So, all right. So what does this mean? In the long run, what we're going to get to is, because phosphorus has 3 empty orbitals, it's ready to form a compound with somebody that can share electrons in those orbitals. And so that's why it's important that we see that. For example, if I go back to, or if I use another example, let's say H2O. If you ever wondered why H2O is H2O, okay, how come it's not HO or H3O or H4O? If we look at the orbital diagrams for oxygen, okay, oxygen's electron configuration is 1s2, 2s2, 2p4. And I'll just focus on the last orbitals of this, the s's and the p's. But I'd get one box for the s there, and then the p's have 3 boxes. I would go through and place these electrons in there, the 2 electrons in the s here. I'll just do it since it's not that big of a deal. There's this filled from the 1s. Then the 4s fill this way. They go 1, 2, 3, 4. Okay? And you see that I have 2 empty orbitals. Well, hydrogen's electron configuration or orbital diagram is the simplest, 1s1, which means there's just a box for the s and 1 electron in it. Okay? And if I happen to have another hydrogen sitting around, which probably would from somewhere, okay, it's going to have a box also, 1 orbital for its s with 1 electron in it. And it's going to look like that, okay? So this orbital is linked to that hydrogen, this one to this, and maybe you can kind of see what's going to happen. There's going to be a bond that forms between these two, right there and right there. And in so doing, when those guys share electrons, they both feel as if they're filled up their orbitals. And that's the mechanism to which you're going to be able to figure out formulas of compounds. So looking back here at phosphorus, okay, I kind of think there might be this compound H3P, and that would be a good guess for a compound that would form between hydrogen and phosphorus, because the hydrogens are going to come in 1, 2, 3 right there, fill up everybody, everybody's happy.